Hey everybody, this is Larry. This is Weekly Contest 441. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So today I'm doing the virtual contest because, well, I don't know, I'm on a mini thing where Leetcode's been having issues with their prompts quality and I'm just not too happy about it, so I'm not doing it live these days along the cheaters and all these things. But yeah, so there's a kink though, is that for some reason, when I start a virtual contest, it doesn't actually start. So what I'm going to do is that I have a window here that I'm manually taking down the time, and I'm using a timer thing on my watch, on my phone. I mean, you can actually look at it on YouTube, I guess, and do the math if you really want, but that's how I'm doing it. So yeah, so that's how we're going to do it. So, which is kind of nuts that, you know, this is the technology we're coming with. All right, let's go. 3, 2, 1. Go, 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 go. And here, if I click on here, it doesn't go to the contest version, and I don't like working on that one. So yeah, okay, let's just go do. Okay, let's go. Let's actually, oh no, I forgot to actually click on the button. Okay, I'm clicking on it now. I'm saving myself like 20 seconds or something, so I've cheated for 20 seconds clicking, but whatever, it's fine. And I'm talking about it, so now it's running, so okay, whatever. All right, let's go. Give an integer array nums without making it empty. Any number, okay. Select subarray. After deletion, all numbers have to be unique and sum is maximized. Any so okay. Oh, they're all unique. And it's just the sum of all the things, right? So okay. So that means that right? So set of nums, okay, so sum of set of nums x for x in nums if x is greater than 0, right? Something like that, right? Pretty straightforward, I think. If I was able to get this right the first time. 1513, I think this is right. Am I going too fast? I am. Huh, okay, so I didn't consider that case, which is fair. Oh, it's some, not some of an empty set. Oh, without making it empty. Okay. Well, GG. I think that's the only case. Okay. Huh. And today I am not a smart boy. Okay. I don't know. Okay, well maybe it's good that I didn't do the contest anyway. I don't know why I'm so bad at this. Okay, fine. So that's 202. Let me actually hit the lap button. Actually, I guess I could have just done the lap button. 204 according to that by the time I clicked on the button. But alright, this is like a traditional speed run where I'm clicking on everything manually. Alright, anyway, closest equal element correct. And I got 2 wrong answers, by the way, so let's actually do plus 10 minutes here. Disappointing. Alright, circular array nums and array queries. For each query I, you have to find the following: the minimum distance between element and any other index j. And what? The minimum distance. What does distance mean? Query 0, 0, and nums of 0 is 1. The nearest index of the same y. Oh, I see. And it's circular. Okay. And it's just binary search, right? I don't think there's anything too tricky about it. So something like that, right? And then so it has to be the same but not dissimilar, right? So then now we just find it, right? So for Q inquiries, F sub Q, we want to binary search this, to get the index, and it has to be in there just by definition. So f of z, is it f of q? No, f of num sub q, right? Yeah, okay, so, well, we have to search it for f, okay, we have to search in f of num sub q. We want to search for q, because that's the index, and it always has to be in there. Okay, fine, right? So then now it is going to be either, okay, so the index, so it's going to be q, f of num sub q of index plus 1 mod length of f of num sub q. So it's q, is either this or the plus version. Oh, actually, I guess subtract version. Whoops. And that should be it. What if that's the one value? Okay, if it's unique, then it is not, right? So, okay, so I think I return 0 in that case. So I could just check for that, because if it's all unique, then it should be not 0. So that's fine, but this is actually wrong as well. Why is this wrong? Oh, because it's not doing the circular math. Okay, that makes sense actually. Yeah, it's annoying though. Okay, so this if okay, let's just do the special case first. If length of f of num sub q is equal to 1, then we just append -1, and then we continue. Otherwise, with binary search, okay, that's fine. I did the wraparound on the circular array, but I didn't do the math on the wraparound, right? So okay, so this is gonna be okay. So maybe I do I don't know. Naming things is hard, so let's just go C for calculation. Right, and then now we have C, A, B, right? So then it's either return absolute of A minus B, or A plus length of nums minus B, absolute value of that, I think, or A minus B minus length of nums, I guess. Something like that. I don't know. Right, looks okay. Let's give it YOLO submit. Come on, okay. Could not stand another one. Ooh. Oh, my thing fell asleep. Okay, lap 4:59.74. Okay, good job, Larry. Did not make a silly mistake that time. Oh wait, no, that's not the time. That's the lap time. Okay. Dang it, watch. Okay, fine. We'll just do the math later. Okay, fine. All right. We have 0. Oh, double check that this didn't change. Oh, actually, it did change. It just added from 130. So okay, very silly, but okay, fine. We could. I don't know if we could do the math from this because it didn't start at 0, so it's very silly. Okay, anyway, let's do this Q3. 3489 0 await transformation 4. Why am I reading it out loud? Okay, you have queries, query sub i's, left right value, select a subset of indexes, determine the value at each selected indexes by exact. Okay, so it's not up to, it's exact. I think that's the other one that we were looking at. 0 return the minimum number of k such that after, okay, processing the first k is generally going to be binary search, but are there anything with the numbers? Y sub I is going to be 10. That's interesting. Num sub length is 10 is also super interesting, but you cannot do brute force on queries, so it's going to be some dynamic programming is going to be my guess. Okay, so what would that look like, right? So Q is in queries. We either have, I guess 0 queries could be true, and then Q is gonna be all the queries, right? So right, mid is equal to, I don't know if I should write this out yet. Maybe that's too early. Okay, so if this is good, then we want to try a smaller thing. Otherwise, we try a bigger number, and we are good. Except for the very hard good function, we have a target. So we want to try target queries, and we want to know if it's exact, right? So we, though this is 10 is actually interesting. That just means we can DP on it. Yeah, and then for each query, for each query prefix, we can just do the math. So that's pretty straightforward, honestly, right? Yeah, okay. So then now we have, it's straightforward, but still have to think, right? Well, it's only, okay. There's only 10, so let's just, yeah. There are a couple of things I want to be clear about, but that's fine. Okay, fine. Yeah, so queries is equal to for, let's see, something like that, right? And then we have for LRV in queries, we want to say for, I don't know, I in range from L to R plus 1, Q of I, we want to append V, right? I don't know how I feel about that, honestly. Wait, am I, oh no, this is 1,000. The values could be 1 to 10, but this is 1,000. I mean, that's still fine, I think. It's just DP. It's just a lot of DP. I don't know if this is fast enough. I didn't really do this one, but okay, fine, right? So then if okay, how do I want to write it? I was going to do it recursively, but maybe that doesn't make sense, right? So num sub I is, okay, so possible is equal to force times, okay, so we have to do it for each I, for X in nums, nope, for index enumerate, because we have to match it with the Q's. So okay, so num sub X plus 1, P sub 0 is equal to true, and then now what do we want to do? So it's only up to 10, so it's only up to 10,000 to 100,000 binary search. That should be fine, actually. Okay, fine. So then now we want to say, yeah, okay, for Y in Q sub index, I don't know why I convert to index, let's just take I. We are going to go from for J in range from X, we go all the way to 0. Actually, we should go to Y, I think, but that's fine. If J minus Y is less than 0, we break. Maybe that's, I don't know. I think that's a better, I mean, it's not a better way, but it's less confusing for me. So then F of J, we just decode that to F P of J minus Y, and then that's it. And then now we have to do if P sub, or if not P sub X, then we return false. Otherwise, then we return all that to be true. I think that's roughly the idea. Okay, well, I mean, maybe not. And -1 has to be impossible, but this isn't quite right either. Actually, 2 means -1, so that's actually good in a way. But also because I did all the queries, that's why. What I need is query sub target, the first target queries. Yeah, I don't know if that's off by 1, but okay. So then now, if left is greater than or equal to, is it Q or Q is the number? So we actually want this to be, okay. It's greater than Q, then we return -1. think that's right. Okay, 2 -144. Okay, let's YOLO go. Okay, good. Tap button. Okay, I mean I have it up here, but okay, 651.70. I mean, okay, doing so good so far. Even if there's so many technical difficulties. Anyway, we have 2 positive integers, L and R. Beautiful. If the product of the digits is divisible by the sum of the digits. Count. Okay, 10 to the 9. The product of its digit is divisible by the sum of its digit. It goes up to 10 to the 9. I mean, the inclusive part is just easy to change, but how do I just count in general? Okay. So by definition, 1 digit is going to work, right? 2, 10 is going to be 11 is not, 12 is also true. Oh no, product of its digits. So actually 12 is not. Is 10 true? The product of the digits is 0, right? Oh, I guess 0 is divisible by anything. Well, okay. So the thing is that it's always going to be so given how do I think about this? So given all of them are this for 2 sets of digits, they're all are gonna be true, right? So okay, well, sum of the digits. Huh. Alright, I mean what I want to do is actually start out by trying yeah, if trying something, I don't know. Print I, right? Just want to see what it looks like for the first 1,000 numbers with force. Okay, S is 0, S cannot be 0, so whatever, start from number 1. Huh, it's okay, so is this like a SIF problem? But no, it goes up pretty high, right? So I don't know. Okay, so any number with a 0 in it has it. That's fine. That's every 10, right? Just because the sum is 0, or the product is 0. The product here is 20. The sum is 10. Oops. Oh, because it's 2 different cases. How many numbers is that? 1 to 100. Okay, so every 10, that means that it's going to be at least 100. But then after that, how many is there? Right? $333. That's just 1/3 of them, huh? But it's not evenly distributed per se. Oh, and it's more than that. It's just all the numbers of, because of the stuff like that. As long as it's not leading, then yeah. So how many numbers don't have a 0? Let's see, and so 153 is still a lot. Do I know anything about these? 1 digit. I mean, I knew that the permutations are working, but okay. I don't know. Ten to the 9. What does it mean? I don't know that I know this one, or what this one means so far. Okay, what's 195? So 45 over 15. Is this a 6-pointer? Oh, people got it very fast actually. But maybe just cheaters. Dare I try a little bit more? They are every 3. Why are they every 3? I mean, they're not every 3, but if we are able to check every 3, that'd be nice too. But can I build smaller pieces? Oh, jeez. Can I combine two digit numbers? It doesn't seem like it. I don't have any idea. I mean, and I'm skipping out the zeros because that's just trivial, right? Or I don't know. We have to count them, but it's trivial to count in theory once we get everything else out. Well, maybe not. I don't know. Either way, we still. Is it just digit DP? How would digit DP work? Yeah, I guess it's just digit DP. Why am I overthinking this? I don't know. I don't know if it works honestly, but it makes sense to me. F of R minus F of L minus 1. I think that's it, right? And then def F, we have X. Okay. Okay, yeah. I'm just thinking about it. Okay. So L is equal to, this is the number of digits. And then what? I'm always a little bit rusty about digit DP. I don't practice it that much. And nowadays I don't practice anything anymore, but okay. You can't do a for loop on everything, right? What would the digit DP look like? Is it digit DP like? Because you do have to keep all that state, and I don't know that it's easy to do all that state. Let's try. I don't know if it is, but we can try. Okay, so okay, let's try it for the first digit, right? So yeah, okay, so the first digit, so sx of I, right? Is the first digit. That means going up to it, we want all inclusive, right? So here we might try that's wrong actually. No, that's the first digit. What am I doing? Okay, it's for I in sx of 0. Okay, so this is the first digit, and then now we want to calculate the, okay, so the sum is going to be just I, and the product is going to be also I technically, but we want to skip the prefix. I think that's the problem with the prefix zeros. So, okay, so we can just brute force this, right? Okay, fine. For L in range of L, so that's for the length, right? So return calc of L, maybe calc total. So this will give me gets the count for all numbers of length L, right? And then yeah, okay. So that assumes that the first digit is not 0. Then we can do for I in range of the first digit, it's going to be from 1 to 9 inclusive, right? So then now that is just going to be go from I, and then we have L minus 1 left, right? So okay, so total is equal to 0. Total, we add this, and then we return total, and we're good, right? And then we have go, we have the total, we have the product, and we have left, number of digits left. This is complete. Gets the count for all numbers of length left to go, right? So if left is equal to 0, then we go if total is mod the other way around, I think actually. Yeah, okay, whoops. Product mod total is equal to 0, return 1. Otherwise, we do stuff, and we should cache this. Total and product should be really not that big, so that's I don't know. I don't know how to analyze this actually. Well, total can only be 10 digits, so it's going to be only up to 100. Product, I guess, if it's 99999 or something, right? I guess it could be 9 to the 9. That's actually pretty big, right? Can I do this better on the product side? I don't know, honestly. I don't know how to handle that. Maybe this isn't the right way to do it. But let's see. I don't know. Maybe there's something we can do to optimize. Okay. Otherwise, then now the next digit is going to be from 1, actually it could be from 0 to 9 now, and then that's actually a little bit awkward. Whatever. So we want to say total plus I and product times I, and then left minus 1. I mean, I guess if product is equal to 0, then we could get it, but that gets cached anyway, so I think that's fine. Right, so if product is equal to 0, then yeah, maybe we can update this, the base case. Then we turn 10 to the left power, right? So because we have 1 digit left, then it's going to be 10. Yeah, okay, I think that's fine. Okay. How do I feel about this? I don't know. Right, so okay, so here we have total is equal to 0. Okay, so then now we have to do the prefix thing, right? So for the first digit, we go from 1 to 10 again. The first digit, not from 10 to, what is it? Int of x of 0, right? So 1 to that, not inclusively. Then total we add to, actually calc, actually just go of total, I left minus 1, or L minus 1. I think that's actually okay. But then now we have to recursively go right, and then calc total, right? I think this is a calc total anyway, but yeah, I think this is wrong. I don't know if it's wrong, but it, oh no, it's not a calc total because it starts off at 0. So okay, so I think this is fine. I mean, it gets memorized anyway, I think. Otherwise, otherwise we go to the next digit. So I think there's like a 4J in range from L here. We go to J. So the prefix is equal to 0. But the prefix product is going to be 1. Prefix sum is going to be 0. So then, yeah, it does this thing, which is, which one is product? PP times this and PS times this. Or the other way around, whoops, PS plus this. And it's not L, it's L minus J minus 1. And then when we go to the next digit, then P. Then PP is fixed, right? Then the PP we times it by int of x of j. Something like this. I mean, I should return stuff. That would be, oh no, I return. Max depth, in which one? Always go left by 1. Line 20. We still left minus 1, so why is that wrong? Okay. I mean, this seemed okay. Well, that's already wrong, but I was gonna say that looks pretty good, but maybe not. I mean, this is as whatever it goes 13. Why does it think it's 13? Don't have the mental energy for this. I don't even know if this is right. Let's actually run it for like, I don't know if it's fast enough. I think that's my problem. We'll see. In my test case, okay, it has to go up to. Actually, that is fast enough. That is actually surprising. Then, okay, maybe I'll give it a think. I thought it might not be fast enough, but if it's fast enough, then I could think about it. Okay. I mean, it's wrong, but, you know, it's fine, maybe. Okay, we can probably play around with... okay, so maybe I'll just do a loop, honestly, for I in range of 15 or 16, from 1 to 16. I f sub I, right? Okay, so one is should be 1, so I think we already messed up there. But it seems like we just why is 1 0 not work? Oh, because I don't so maybe I'm off by 1 somewhere, but that's fine. Maybe it's not great though. 10 should be good, but 11 is not, right? Which is refracted. 12 divided by 2 is... No, 12 divided by 3 is fine. Do I misunderstand this? Oh no, it's 2 divided by 3. I always forget. 2 divided by 3 is not right, so this is not right. Why is 1 wrong? 1, 2, 2. I could see why it's wrong though, because here doesn't do anything, here doesn't do anything because length is 1. So okay, so it takes this 0th element. Oh, I don't check the actual number itself, I think. Okay, so that's why. Actually then here, if pp ps is 0 to 0, total increment by 1. I think that should fix that, but yeah, okay, well ps is gonna be 0. Why? Oh wait, this isn't right actually. This should be outside, so that's actually very awkward. P sum cannot be 0, right? Why could it be 0? That's actually weird. I mean, we do actually have a 0, but why? Oh, because the input is 0. Okay, fine. I mean, we can just, I don't know, if x is equal to 0, we just return 0. I think it's fine. Okay. I mean, it's not the... What? Okay, so here, I mean, this is still... No, this is right, I guess, because there's a 0. But 11 is 9 is very wrong. Right, okay, so... 2 and 9, okay. Oh. Actually, no, it's mostly right, but it's missing by 1 number. I don't know which one though, because if these are 10, it's actually accurate, because none of these numbers are right. I'm off by 1. So 10, what is 10? 10, we do the calculated total, so okay. So that means that we should be doing calculated total on the first one. Should be 1. Oh, I know. Because of the rest of the digits, it should be 0. That's why. Okay, so that's why this is so awkward. If start is equal to 1, if j is equal to 0, start is equal to 0. That's pretty awkward though, but it's fine maybe. Actually, it's the other way around, I think actually. Okay, so this looks good, but is it fast enough? I think that's the part that I don't know. I mean, it looks fast enough. Is it right enough? I don't know anymore. 2 and 10 is right? Okay. I don't know the answer, so I can't check, but I just want to check the speed, and that is obviously going to be the worst case. Click submit. Yes. Okay. Oh, click my timer. Stop. Okay. So this one took me 26 minutes. Yeah. And the funny thing is that I didn't get any wrong answers except for Q1, which is actually embarrassing. But it took 40 minutes. So how? Okay, if Leetcode wants to load, that would be nice. How long would it be if Leetcode didn't suck? What would be my rank? So it thinks that, oh, actually it fixed it. Huh, so I lied. Okay, so Leetcode did sometime fix it, so I don't need my sketchy notepad thing. And I think the timing is roughly right. It matches my thing by within 5 seconds, which I was just messing around anyway. So I guess it figured it out. Alright, not bad. Let me take a screenshot for whatever. So okay, I mean, so we don't have to actually use this crappy edit pad thing. But I did have 2 wrong answers on, so I would have been 109th, which including all the cheating is actually pretty nice. But actually, I don't know, because this one's for Q4, I was a little bit YOLO to be honest, because I don't know I couldn't prove the complexity on this because of this product. Like the numbers can be big, and I know that not all the numbers are possible, right? So how would you put the bound on this as a thing? Total can only go up to what's it, 9 times 9 digits or something, but let's just say even 100 for a thing. Product is actually what is product? Okay, well, with 1 digit it's going to be 9, right? Let's see. I think this is the hard part of the problem. Everything else, I mean, I was slow, but fine. 2 digits, it's going to be the number of, so it's not 9 times 9 because they're not unique, right? Well, it's 9 times 9 divided by 2 for 2 digits, I think. I don't think there's any difference. But after 3 digits, it gets... after 3 digits, it gets become like... it's like an n choose 3 type thing, right? So then, yeah, okay. So then it is... So after... So 3 digit... Okay, so... 1 digit is going to have 9, right? 9 possibility. 2 digits is going to have if we want to go for it, then it's going to be it's not 9 well, okay, so we can break it down by 1 unique digit, which is 9 choose 1 times 9 plus 9 choose 2 times Is that it? No, wait. Am I thinking this way? Okay. 9 choose 1 times 9? Where does that come from? 9 choose 2 sounds right. Man, my math is terrible. I think this is right though. Because you have 9 choose 2, right? Because they give every 2 digits and they're distinct, right? And it gets a little bit harder, well, I mean, if it didn't already, which is then now you have 9 choose 1, then you also have 9 versions of these, right? And No, you don't have to. That's why I'm confused. Okay, so you don't choose times 9 because 9 choose 1 is the 9. You have 9 digit, and then you have 9 choose 2. But this part is the tricky part because now you have 2 digits in 3 things, right? So then now, and the only way to do that is pass 2 to 1, right? The it's gonna be, what's it called? Yeah, 2 1. That's the only way. But and then there's 2 ways to do that for each pair, right? So I guess it's just this times 2 maybe. Yeah, because you choose. I think that's right. Plus 9 choose 3. And then I think that is a 111, so that's right. So I think this number is just the number of what's it called? Like what's it, integer divisions of, I forget what it's called. Like distribution of integers something. Right. Like in this case, 9 choose 1, it can only be a part, like if you think about it as like a visualization, then you can only have one thing of 3, right? Or one number, or 3 of one number, sorry, the other way around. 3 of one number. Here it has 2 of one number, 1 of one number, or the other number, so that's why you have times 2, because it could be backwards. Maybe, I don't even know. I mean, I think for me, the actual number, maybe it matters, but it also doesn't matter. I just want to get like an upper bound kind of thing. So multiply by 2 is not that interesting for now anyway. Maybe we could do on that, and then we just have yeah, one way for 3 numbers. Maybe that's the way to do it, because that has to be 111, and then it gets obviously even more crazy. But 9 choose 1 plus 9 choose 2. 9 choose 2 now is tricky, right? Because then now it has yeah, I think it is just the number of ways to unique, because then now it's 2 plus 2 or 1 plus 3, right? I forget what it's called, but actually, this is actually just now that I see it, this is actually just 4 times I mean, the way that I did this with is 2. So if you're going to rewrite this is actually like a 2 and 1. I write as 2 plus 1, or 1 plus 2, or 2 plus 1. But as a result, you have n minus 1 of these, right? At least for n. So here, this is times 3, because you have 1 plus 3, 2 plus 2, and 3 plus 1. It still gets trickier though, because 9 choose 3 is different as well, because then the combination is going to be 1 plus 1 plus 2. I guess that's it, actually, right? I mean, there's 3 ways to distribute the 2, but that's the only way, so maybe this times 3. And then if it actually looks, and maybe I'm very silly here, but you can maybe see the Pascal's triangle, right? Which is kind of just like a ridiculous thing that I don't know that I expected to see, right? Because then now, and maybe you should expect, because then now, first, every number that's here, it is just adding 1 to here or here, right? And then as a result, that's how you get Pascal's triangle, which is also a ridiculous thing. Also, and here, or every possibility here, it's just from 111 or one of these and getting here, right? So it's I don't know if the math is quite right, but I think you see a Pascal's triangle thing. But that also means, but there is this prefix, right? So it's not quite that, but oh, if you want to comment us saying it is stars and bars. product is based on factorization. Again, to the math, distribution length of all to the exponent set. Yeah. I'm just trying to find an upper bound for 9-digit, right? My intuition would say that it's not so bad, but I don't know. I'm just bad at math. I think that's the thing. It's not quite stars and bars, right? Though some parts of it you can think of it that way. Well, maybe it is. Maybe my math is just bad, which would definitely be true. Oh, I guess it is, actually. You're right. Okay. But then it's the summation of all the things, right? Does that sum to anything? Because basically this is saying that, yeah, the star and bars make sense, because then now you have five things, right? So you could have 1, 5, and then you're happy with no distribution, and then plus the number of ways to have 1 bar. I guess 1 bar has to be in the middle. So then that is, so another way to think about that then, right, is this is, I mean, you have to, yeah, I think that's fine. And I think the 9 choose 1 thing is confusing. I think if you take away the numbers on these, so we can still do the numbers, and the bar is the number of ways, because given here, then now this is just 5 factorial over 1 factor over 4 factor or something, right? So then it's still hard, but I think maybe there's an upper bound as a result. I don't know, right? Because okay, so let's say you have 9 digits, right? Then it is just you have 9 things, which is going to be just what 9 choose 0, right, or whatever. Or yeah, well in this case it's 9 choose 0. But and times 9, because each of the stars can be any number, and then for each contiguous. No, I mean I get that. I get how to use it. It's just that like the concepts is not what I'm having trouble with, right? It's actually plugging it in. Or rather, I'm trying to find a limit, right? And for me, it's not clear. Like we can do the math and calculate this out, and that's fine. And in fact, what we should do is probably write code to generate that, right? But I guess what I'm more interested in is not necessarily that, but it's that in the future, if I see a similar pattern, I would know that, like for example, if we don't have to multiply by whatever, and you have just the summation of all these things, and then you know that this is basically Pascal's triangle thing without the multiply, like without the digits, then this is just Pascal's triangle, and then you know that the nth row of Pascal's triangle, the summation of that is 2 to the 9, right, on the 9th row. And that allows me to kind of be like, okay, I'm confident. I know that's gonna be 2 to the 9. That's good, right? For me, the issue is that with this extra complication, I don't know the upper bound to do it. Yeah, I don't know the right way to think about this in terms of like my what I'm trying to figure out is that for future contests, for future problem solving, if I have a similar thing, is like, but maybe the digit is not 9, maybe the digit is 12. Do I know what the upper bound is? And will I have enough confidence to implement it, thinking like before solving for it, have confidence that it won't time out before I implement it, right? So I think that's what I'm trying to solve for. And maybe we could figure it out. I mean, it's not that hard. Like, this is actually a fun, interesting problem to solve as well as a dynamic programming problem, right? It's not, but yeah, and we can actually, I don't know, is there, I feel like we can probably actually write that out really quickly too, right? Let's see. We could write that out really quickly in terms of the number of unique products that can come up with x digits, right? So maybe we can write another one as an up south. We can we write what this is, right? So here we have digits left, so we have left, and then the current product, right? So we can just write it. Like if we really want to write we want to know the exact number, we can. It's just that I wanted an intuitive thing, right? So here's the first digit, right? Yeah. Yeah, I mean, I think that's fine, right? So here, maybe we'll just cache it so that we don't even have to cache it. We just have scene as equal to, no, I mean, we should cache it because why not? And then here, the first digit, we just go from 1 to 9, right? And then maybe we have for L in range from, let's just go from 1 digit to 9 digits. So again, right, so here we want to say the first digit is going to be L minus 1, right? Yeah, and then maybe we set total is equal to here. We add this. Oh, we don't even, no. We don't need to. We have a scene array. We calculate this, and then we just print out the length of scene, right? And then here we go, if left is equal to 0, then scene.add p, right? Otherwise, then we just for I in range from here, we can go from 0 to 9 or 0 to 10, right? Or well, 0 to 9, but you know what I mean. We could go to p times I left minus 1, right? And that's it, really. We should return, and then now we should be able to see L and scene, right? So we can write that code really quickly, right? Scene is equal to z of 0. Did I have a 0 somewhere? Whoops, I just typed it in for some reason. I don't know. Okay. Go to text 2 per. Oh yeah. How did? Oh, I think I was just writing and thinking of the other one. Okay. Yeah. So one digit has 9. Huh. That doesn't feel right though, right? Am I doing this wrong? This feels small. Or am I wrong? I mean, let's take a look real quick. Right? So with one digit, 1, 2, 3, 4, 5, 6, 7, 9. With 2 digits, a lot of them is going to be 0. So that's 10 is going to be like 5 times 2, 6 times 2, so 2 times stuff, 3 times some stuff, 4 times. So maybe there's only 1,000 possible numbers. I mean, we do all this math, and it's just that the number of unique numbers is 1,000, right? So I think that's basically the key for this one. It turns out is that product. There are only 1,000 unique products, which I find fascinating and surprising. We do all the math, and we just had to write like 5 minutes worth of code, and we're Gucci. So I don't know. You got? Am I wrong? I mean, I know that it's going to be a lot. Obviously, it's going to be a lot less than 9 to the 9, because if that's not the case, this would obviously time out. But it's just, it's not about knowing. It's about like an order of magnitude, so that you can, at least for me, right, figuring out in the future. But I don't know if I'm doing it wrong. If there's only 1,000 unique things, but that's a lot fewer than whatever you're saying, right? Because the thing is that this also dedupes, like for example, 18 is 2 times 9, but also 3 times 6 for 2 digit, right? So this is actually going to be a smaller number than doing it this way, because you dedupe on that, so it makes it even more fewer dupes or more dupes, right? And I guess as a result, there's just a lot of things like that, because 2 times 9 is equal to 3 times 6, so the product, like the number of unique products is even smaller, and it turns out there's only 1,000 unique products, which is a very round number, by the way. So that's also a little bit wonky, if you ask me. Is that even, how can that, this also doesn't, oh no, okay. So, okay, I see. So this is not the prefix sum. This is just 1,000 numbers of exactly 9 digits. So I didn't prefix that. So in that case, we could just take this out, and then we could get the prefix number, and maybe that's what you were saying. Yeah, okay, but still only 3,000 though. So maybe there's some dedupings there. I don't know what is. Yeah. No, it's still not available during the contest because I guess we're still technically in contest. But yeah, anyway, that is all I have for this contest. Turned out I did pretty okay. Hit the like button, hit the subscribe button, join me on Discord. That was a good review. That's a good upsell. I thought it was an interesting thing. The 10 minutes on this is silly though. If I didn't have the 10-minute penalty, I finished 109, they claim. If I didn't have the 10-minute penalty, I guess 75. That's actually surprising. Like how little it dropped from, I guess 140 position is actually a lot. But yeah, thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.